Video 50. Put it there, man. Our
Our
golden video. We're having a pizza party when it hits 100, I promise. All right. So today we're going to talk about simulations. And we're going to use tables of random digits to do the simulation. We did coins, dice, and our calculator in class.
Yeah.
But on the AP test, probably going to be a table with random digits.
Right.
Okay. So let's talk about how to set it up. Okay. For our first problem, suppose a soda company has decided to place free tickets to a concert on the side of certain soda cans. Mr. Lewis, what was the last concert you were at?
last concert I
Yeah.
was at? Dave Matthews Band.
Okay, cool. So it could be Dave Matthews Band or something like that. So free tickets on the side of certain soda cans. The company has placed free tickets on 20% of the cans. It's actually a lot of tickets. The other 80% of cans do not contain the free ticket. If you and your friend want to both get free tickets, how many soda cans on average will you need to buy to get 2 free tickets? Okay, so we're going to use simulation to try to find this out experimentally. So the first part of the simulation is to describe the simulation. This is actually the important part. So Mr. Lewis, we're going to use the random digit table. And since this involves percents, they're nice percents, but let's get in the habit of using 2 digits for percents.
Yeah.
So we can get away with one. So use random digit table and take 2 digits at a time.
2 digits at a time.
Very good. So then we have to assign the values. Like if we use the first row, first 2 digits are 77, but right now that doesn't mean anything.
Right.
We have to define what it needs.
Mm-hmm.
Now, the digits go from 00 to 99.
Right.
Somehow we have to assign 20% of the numbers to be a free ticket and 80% to be not a free ticket. All right, an easy way to do this is let the numbers 01 through 20 be a free ticket. And then let 21 through 99 and 00 be not free ticket.
So
the reason why is I can't think of 00 as 100. That way we can go from 1 to 100. So you can do this a lot of ways, but 01 through 20 be a free ticket. That's 20 numbers. Then we're going to let 21 through 99, and you have to include comma 00. Like I said, in my mind, that represents 100, equal a not free ticket. The last thing, not a lot of room, Mr. Lewis.
nope.
But the last thing is we have to describe when it stops. So each of these is a component. Selecting one can is a component. The component is like the most basic part of the experiment. Trial, we have to describe when a trial, the entire experiment ends. So the experiment ends when we get 2 free tickets.
2 free.
So we describe what we're using, how the numbers are assigned, and how it ends. Okay,
All right.
so we're going to use the first row to do a trial. Mr. Lewis, I like drawing a line after the pairs of digits. So after the first 2 sevens,
Bam.
and then after the 4,
Bam.
and then I'll just do a few. I don't know how many I need, but let's just do a couple. We'll figure out how we need. So 77, 74, 15, 06, 33, 58, 51, 40, 83. That's probably enough. Those are my first numbers.
Okay.
Okay, that's 77. The way we defined it, that 77 is not a free. Maybe put an N above that for nope.
Nope.
74 is a
Nope.
Nope. 15,
Yes.
that's a win. 6,
Yes.
we're done. We got our 2 free tickets.
Okay.
So for the first trial,
4.
it took 4. Okay, let's do the second trial. So again, I would divide it out. Let's start on the second one.
Okay.
Technically, you can start anywhere. You can just jump into the table and start anywhere. But
All right. 42.
yeah,
That's a no. 75. No. 23. No. 52. No. 75. No. 57. No. 70. No. 56, no. This is not a good row. 38, no. 55, no. 92, 29,
08.
08, that's a win. 62, 86, 24, 99, 86. Hey, here's our second win.
Wow.
19. So, how many was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We got 19 cans that time.
So, due to a massive miscalculation by Mr. Miller,
Yeah.
we're just gonna do 2 trials. But we would just start on another row. We can't trim down the table at random digits so we could see it. We trimmed it a little bit much. So, but that was 2 trials, and then you could take the average to find it. So, for our 2 trials, 23 divided by 2 is 11.5. Now, I wouldn't bet on that a lot. Why, Mr. Lewis?
Because it's a very, very small sample of trials.
Yeah, you have to do many
Yeah.
simulations to get at the answer. But like I said, computers were designed to do this, and you can easily write a program to do this a couple million times and get it. So AP Stats, we're not looking at our answers actually be a good answer for the problem. It's all about, do you understand how to set it up?
Right.
Then you could spend all day using a random digit table if you want. Back in the day, that's what they would have done. Okay, so let's go on to the next one. Like I said, the key is setting it up.
Yeah. All right. So here we have your friend has calculated that if she wakes up late, she has a 10% chance of being early to school, a 30% chance of being on time, and a 60% chance of being late. If she wakes up late every day of a school week, it's 5 days, what is the probability that she will be late to school each one of those days?
Okay, this time I know we have enough digits.
Okay.
Let's take 2 at a time. It's a percent problem. And again, we could get away with 1 because they're multiples of 10. But the way I like to handle percent problems, let's take 2 digits at a time. And then here, let's let 1 through 10
1 through 10,
be that she's early to school.
early.
This is very realistic, by the way. Let 30 be, so we're going to let 11 through 40.
That she's on time.
Okay. So if you do 40 minus 11, it's 29, but you have to include 11.
Right.
That's 30. So you think, so it's 1 more than what you get when you subtract the numbers. Let 41 through 99 and 0, 0. So since we have 1 through 100, that's why I can't do it that way. Okay. Now, we're going to do 3 trials. So each day is a component, and then it stops after 5 days.
Right.
So we're going to do 3 trials. We're going to stop after 5 days. Okay, so on the table,
Okay.
let's divide up the first row and get our 5 days.
Okay. So here's 1.
Yep.
2.
Yep.
3.
Yep.
4. 5.
Okay, first day, she was
On time.
on time.
So
Yeah.
OT.
OT. Number 2,
OT.
good girl. Number 3,
OT.
wow,
Well, beating the average.
50.
Late.
Yeah. 34.
On time.
Okay, so that was,
She was late 1 day.
okay. All right, second try.
Okay, so we got 05.
Let's do the second row. We can start second row.
Oh, I'm glad you guys are in there. I did one of the things, but I forgot.
73.
Sitting there.
Yeah.
67.
64, 71,
And
50.
50.
So that first one,
Late.
second one,
Late.
third one,
Late.
fourth one,
Late.
fifth one.
Late.
Bad week, man. Late all 5 times.
Yes.
All right, let's do the third trial.
Okay. 1, 2, 3, 4, and 5.
Okay.
So she was late. Late. Late.
Oh man.
on time,
Look at
and
this.
early.
Early. Get out. Give her teacher a heart attack. So
three.
now we're going to answer the question. That was 3 trials, not very many, but it gives us an idea how to do it. And it says, what's the probability that she will be late to school on each one of those 5 days?
Yeah, because we totally didn't write that. So average number of late.
What's, oh yeah, oops. So yeah, we can do her average number of late. So,
So
she was late.
I'm gonna say she's gonna be average late 3 out of 5 days. So probability wise, that would be 60%.
Yeah. Very good.
Okay.
Most important part, setting it up. So if you kind of forgot the probability, it won't be so bad for the simulation. And we're going to become experts at probability soon after the Christmas break.
Yes.
Okay.
All right. Now it's your guys' turn. All right, so the journal assignment for you, we have the chance of contracting flu when coming into contact with an infected person is an estimated to be 35%. Suppose that a family of 5 comes in contact with an infected person. Using the simulation, we want to know how many people would get the flu.
It's very realistic. There are 5 people in my family.
I know, there you go. May the
Okay.
odds be ever in your favor.
So remember, yes, we're using the random digits, how many we're taking at a time, and you got to define what the numbers mean. And so 35% of the numbers can represent getting the flu, and the remaining numbers not getting the flu. And then show us the 3 trials. How many got the flu in each trial?
Yep.
Okay, good luck.